In this video, we'll look at the Sanotronics simulation problem from the textbook. We're going to break it down into the 4 parts demonstrated in the book. First of all, we're going to create a static model that gives us one value. Then we will set up a probability section that will allow us to generate our random values given the properties of those values, and we'll talk about those properties as we work through that. Then for the third step, we'll set up the data table that will replicate this model 1,000 times. Then we will generate a summary statistics section and create a histogram to evaluate our findings. So let's begin with step 1. If you don't have your worksheet set up like this, you'll need to pause the video and set your worksheet up like this. Be careful to place your values in the same cells, otherwise they may not match as we get further into the exercise. In the text, we're provided with some values with which to start the exercise. We are provided a base case scenario that gives us a selling price of $249, a admin and advertising cost of $1 million, a direct labor cost per unit of $45, and a parts cost per unit of $90. I'm going to very quickly format this $1 million so that we can see that it's $1 million. Sometimes with so many zeros, it's hard to know if you have 10 million or 100,000. There we go. And we're told that the demand in the base case will be 15,000 units in the first year. I'm just going to take that format from the million and place it there as well so we can see that clearly. Now we need to calculate profit. We're given a formula for profit. 16.2 is the equation number in the text. We're just going to take our incremental costs, which is a selling price per unit. That's revenue. We'll subtract from that then the incremental costs of direct labor per unit minus parts cost per unit. We'll take that value and multiply it times the number of units, the demand, and then we will subtract from that our fixed cost of operations for that first year. That gives us, I'll go ahead and copy that format. That gives us the profit in the base case scenario. Now to create a model for Sanotronics, we need to know something about the costs. We have been given some information about direct labor cost and parts cost per unit. We also need some information about demand, and we're provided with that information as well. We're told that direct labor costs follow a discrete probability distribution, and I've set up a table for that distribution here. If you don't have this, you'll want to pause the video and type that in. It tells us that there is a 10% probability that labor costs will be $43 an hour, a 20% that will be $44 an hour, 40% $45, and so on. So we need to create a discrete probability distribution table in order to allow Excel to randomly select these costs in our model. To do that, we'll create columns for the lower and the upper bound. We use the upper bound to create the next lower bound value, but it is the lower bound and the cost per unit that are the two values we're really looking for. The lower bound initially is always 0, and it's important that our costs are sorted from low to high. So we place that in. The upper bound is always the lower bound plus the probability of that cost. The upper bound for the next value is the lower bound for the previous cost, and that upper bound is simply the lower bound plus the probability of that cost. Once we have these formulas are the same all the way down, so we just copy them down. We can see then the probabilities. We know the table is correct because the initial lower bound is 0 and the final upper bound is 1. These values must take on values from 0 to 1. Then we're provided with some information regarding parts cost. It follows a continuous probability distribution, and we'll construct that formula in our model. But for now, what we need to know is the lower bound for that, $80, and the upper bound for that. The characteristic of a continuous probability distribution is that the cost can take on any value between the lower bound and the upper bound with equal likelihood. It's a uniform distribution. And finally, we're provided with data regarding demand. We're told that demand follows a normal probability distribution with a mean of 15,000 units and a standard deviation of 4,500 units. So we'll put in 15,000 and 4,500. And I'm going to copy this formatting just so that I can be sure that I've entered these numbers correctly. Use the format painter to do that. Now I have the values that I need to create the random values used in my model. Now for part 3, let's set up the data table for the model. If you don't have these titles in your worksheet, you need to pause and go ahead and put them in. We're going to run 1,000 simulations of this model, and they do it a little differently in the textbook. They use a data table, which is good. We need to introduce you to data tables in Excel. The way they've set this up, though, data table really isn't necessary, but we'll go ahead and follow the textbook example for now. First thing we need to do is create a column of numbers from 1 to 1,000. There are a couple ways to do that. We've done them, these columns previously in class. We have started the series with 1, 2, and then use the autofill node to drag it down to 1,000. But you know, that gets kind of difficult, especially if we're going to do 10,000. You just have to keep dragging and scrolling down all the way down to 10,000. Another way to do that is to enter the first value of the series in the cell. Place your cursor on the cell, then from the Home tab, select Fill and Series. Then we want our series in a column. Columns, we want it to run down, not across. We want it to step 1 increment at a time. We don't want to count by 2s or 3s. We want to count by 1s. And we want it to stop at 1,000. I say OK. And that gives us this series. And if you take a look, I'll end down arrow. It goes all the way to 1,000. I'll bring that back up. Now, direct labor costs were described as following a discrete probability distribution, and we were given this table. So we're going to use our random number generator, a pseudo-random number generator, to generate these values. We'll use the VLOOKUP function in this case because the lower bound is the first column in our table, but a lot of times it's not the first column, so you just use the lookup function in that case. But we'll use VLOOKUP for now since the textbook uses VLOOKUP. So we'll go ahead and enter VLOOKUP. And for the value to look up, we have a range here from 0 to 1. We're going to generate a random number, which generates a uniformly distributed random number between 0 and 1. And that's rand, left parenthesis, right parenthesis. We'll go ahead and we'll look that value up in the first column of our table, and here's our table. We're using VLOOKUP, so we need the whole table. We could probably stop here. That's all we need. And we need to make that absolute because we are going to copy this down. The column index we want is our cost per unit is in the third column in our table, 1, 2, 3. So we'll go ahead and when we find the random value in our first column, we'll go to the third column and take the corresponding value. And we're looking for an approximate match in that case. Where if we use lookup, lookup always looks for an approximate match. And we press enter, and there we have our initial value. Parts cost was described as following a uniform distribution with a lower bound of 80 and an upper bound of 100. So we are provided with a formula 16.3 in the textbook that tells us that if we take the lower bound equals the lower bound, and let's make that absolute, and if we add that to the quantity, the upper bound, make that absolute, minus the lower bound, again absolute, and then if we multiply that times our random number, our random value, we will get a value in that distribution, a continuous value. So the value will have decimals representing our parts cost per unit. Let's just take some of those decimals out. We could do that without decimals. The text talks about the problems associated with leaving decimals in there, but we're just going to leave the decimals in. That's what the text does. I'll show them here. And I'll add a couple of decimals here to show you that there are no decimals here because it's taken from our table, which is a discrete table. And demand is defined in the text as following a normal distribution. So we've used the normal distribution to look up the probability, the area under a curve, a value between 0 and 1. We can use another normal distribution function too when given the probability, the area under the curve, it will return the value that has that probability, and that's what we want. It's called the norm inverse function. So we'll use norm.inverse, and we'll give it a probability, and we'll use the random number generator to give it a probability. And then it wants the mean. Well, we have a mean. We were given a mean, and that's absolute, and a standard deviation. And with those two values, it will give us a randomly generated value that is normally distributed, that has the characteristics of a mean of 15,000 and a standard deviation of 4,500. So we press enter, we get that value for demand. We'll just make that up. Let's just format it like we formatted those. We use the format painter. Now we come back and calculate profit. You notice every time I change something, these values change. Your values will not match my values because we're using the random number generator. So you need to make sure that your formulas go in accurately because you can't look at the results and compare them with my results. Now we go back to our profit equation, and we'll take our incremental costs, which are selling price 249. We'll make that absolute. That's from up there. Minus, we want the direct cost. Let's take the direct cost from this iteration of our experiment. That'll stay relative because we want to copy that down as it goes down. Minus our parts cost. Leave that relative times our demand. Leave that relative minus our overhead costs or fixed costs, and we'll make those absolute, and that will give us our profit per iteration of our model. I'm going to go ahead and use some formatting to make this a little more readable just for this first time around. Now the book suggests that we use the data table to calculate the rest of the simulation. So to do that, I need to select the entire area. So I'll go over here to my simulation trial, hold down the Shift key, and then right arrow over to get profit. Then still holding down the Shift key, I will do the end key and release, and the down arrow key and release, and there I've selected my entire area. Now I'll go up to Data, the Data tab, and go to What If Analysis, and select Data Table. Puts me back to the top. I want to scroll all the way to the top. I need to select a cell that I'm not using anywhere. And that's just going to be a cell that Excel is going to use. You're not going to see anything as it creates the data table. First, I need to indicate the type of input, and it's column input. You'll notice that our input values are in columns along the top. So it's going to look at that first row across the columns and see the input values. And I'll use cell D1 because I'm not going to use that cell. You can use any cell that you're not going to use. I recommend you use something on the sheet instead of way out here. And when I do that, select OK, you can see that now it creates my data table. It selects values at random here. It takes a while because now it's regenerating that table every time I touch a key, change a value, so you'll want to be careful. We'll talk about that a little more in class. You can see that these are table values. If you look up here, you see that they're being drawn from a data table. Now the text continues the exercise by generating some statistics. If you don't have this row of values here, go ahead and pause the video and enter these. It wants a mean, a standard deviation, want to know the minimum profit and the maximum profit. And then they want to know the probability that profit is less than 0. All right, so to get these, we'll do the mean of the profit. We're just going to take the average, and we're going to take the average of all of our profit values. Now click here, hold down the Shift key, press and release the End key, press and release the down arrow. I see that that goes all the way down to row 1021. I'll put a right parenthesis in there and press Enter. Now we can see that we go to row 1021 for each of these, so we don't have to go down there all the time. We can just type it in. I can take my standard deviation equals stdev, and I'm going to use the standard deviation of the sample, so .s. And I'll begin at E22, which is where my values begin, and I'll go to E1021 to get my 1,000 values in there. That way I don't have to scroll down. I press Enter. It takes a minute. The minimum profit, we'll go ahead and again get the min value of our E22 to E1021. Gives us the minimum. And then the maximum, which is the max of E22 to E1021. And then the probability that profit is less than 0. So all I'm going to do, I'm going to use the COUNTIF function. And I'm going to take my range, which is E22 to E1021. And in that range, the criteria I'm going to look for in quotes is less than 0, close quote. That'll count the number of times it's less than 0. And then if I place that over 1,000, which is the number of trials, that will give me the percentage or the probability of a profit that is less than 0. I press Enter, and it's 0.085. You can reformat these a little bit so that they are a little more readable. We might just take the format painter here and paint these. There you go. The text then goes on to create a histogram, so we'll do that. They use bin and frequency because in the text they talk about using The frequency function in Excel, that's a data function. We're not going to get into data functions in this course, so I'm going to show you a way to do it. It's very simple using the functions that we've already learned. I'm going to start, they want to start this at minus 1.5 million and take it all the way to 300 million in quarter-million steps. So let's start this with minus 1.5 million. And I'm going to format this using the format painter. And I want this to go up by 250,000 each time, so I'll take the value above and add to it 250,000. And then if I copy this down to row 40, that will get me to 3 million. There we are, 3 million. Now I can go ahead and, so I'll use my count if function, and I'll look at my range E22 to E1021, and I'll look for profit values that are less than or equal to space, ampersand, space, and then I'll just take the value to my left in this case, press enter. Now to show you how to do these, I'm going to scroll over a little bit so that you can see the functions as I type them in. What I want to do is I want to look for values between this range of values here, all the way down to the last one. So I'm going to go ahead and use my count if s statement. It gives me a chance to look at multiple search criteria. So count if s. And then I want to take, these need to be absolute references because I'm going to copy them down and I'm going to just type them in. So $E $22 colon $E $1021. And then I want to look for less than or equal to, has to be in quotes, ampersand, space, and then the value to my left. So if it's less than or equal to that, comma. Now it asks for my criteria range 2. My criteria range 2 is the same as the other one. It's $E $22 colon $E $1021. And I want it to look for values that are greater than, in quotes, ampersand, space, the previous value. I'll close that off and press enter. And that will return a 0. There aren't any, apparently. But I can take this now and I'm going to copy it down to just before the last one. And that gives me the data for my histogram. Now for the last one, I'll go back to my count if function and I'll say count if, and I'm not going to copy this, so I can just get my values E22 to E1021 and quotes greater than or equal to, close quote, ampersand, space, this value to my left, and close that off. And that gives me a 0. Now I can come up here, come back over, draw my histogram. I'm just going to put it right here. I'll put my cursor out here in the middle of nowhere so Excel doesn't try to help me. I'll insert, and I'm just going to insert. They have a histogram option. I wouldn't use it. I'm going to just insert a column chart. And with the chart selected, I'll go up here to Design, the Design tab, select the Select Data tab. Then I'll add my column of values. The series name, we'll just call them frequency. This, it'll make it that chart title for now. We're not going to worry about formatting this chart. We're just going to make it. Then I need to take out this 1, leave the equal sign in. You could tab and just put equals either way you want. Then I want to select my values. All right. I have those. Then I need to edit the values for my x-axis. Those values need to be the bin values. And press OK. OK again. And that's how you solve the Sanotronics problem. in Chapter 16.